In part 1, we looked at off-screen buffers. We saw that this was all we needed to know. We declare an object of type pGraphics and create it with a call to create graphics. We bracket all of our drawing calls by sending the messages begin draw and end draw to the object we've made. Between those, we can draw any kind of graphics we like, always preceding each call with the name of the pGraphics object and a period. Finally, to draw the result on the screen, we just transfer it with image, where we also supply the upper left X and Y where the buffer should be drawn. Let's use this to make the two examples we saw in part 1. I'll start with our first example, an object with complicated transparency. The key thing here is that all off-screen buffers start out completely transparent, and if we draw into a pixel but later set it to have a transparency of 0, it goes back to being transparent. Then when we copy the buffer, transparent pixels simply don't get drawn. As always, we start with the graphics window, and I'll begin just by drawing a photograph in there by calling image. Next, I'll create an off-screen buffer that I will call ring. Here I'm showing that ring is completely transparent by using the familiar gray and white checkerboard pattern that we're familiar with from graphics programs. So if I was to copy ring on top of graphics window right now, there would be no change to our graphics window. In order to start drawing into ring, of course we send the message begin draw to ring. And when we're all done, we'll call ring.endDraw. The first thing I'll do with ring is tell it what color to fill with. And here I have kind of a light blue color. Now I draw a rectangle. And this works just like we would always expect. If we now copied ring onto the graphics window, we would be drawing a blue square on top of the graphics window. And everything outside the square would still be the photograph because those pixels in ring are transparent. Now I want to knock some holes in ring. The way I'll do it is I'll imagine that each of the 4 circles I want to draw is located inside of a square. So I'm going to write 2 loops, one for Y and one for X, that look at every pixel in the square. If the pixel is inside the circle, then I will set the pixel to transparent. And the way we can do that is to simply call set. But of course we send the message set to ring, so it's ring.set. And that pixel XY gets a color that has a 4th value. Remember from our discussion of colors that if you provide a color that has 4 values, the 4th one is transparency. So here I'm filling it with RGB000 and a final value or opacity of 0. So in fact, the RGB values don't matter. I'm saying that this pixel is completely transparent. The result, if we look back at the ring buffer, is that we've now made all of the pixels in the circle transparent. Well, I just do this 4 times. So I'll do exactly the same thing for the square in the upper right, making a transparent circle. Then I'll do it 2 more times, once in the lower left, once in the lower right, and now I have this pattern. Now I can just copy that in by using image. And when I draw a ring on top of the graphics window, we get the result you see here. If at any time I use the keyboard to change the shape, I make the circles bigger or smaller, or I make the whole square bigger or smaller, then I throw ring away and I build it again. It just takes a moment. And then on every frame, I just call image and bang, there it is. Now let's look at our other example. As always, we start with our graphics window, and I create an off-screen buffer that I call fuzzy. As always, before we start drawing into fuzzy, not only do we have to create it with a call to create graphics, but we have to call fuzzy.beginDraw. Then we draw everything, and when we're done, we call fuzzy.endDraw. The first thing I do is I draw my photograph into the fuzzy buffer. So fuzzy.image, and it just takes the normal arguments, the photograph I want to put in its upper left corner. Here's 0, 0. Now I want to draw a letter. So I tell fuzzy to fill with 0. I tell fuzzy to set the text font to be my font, and then I tell it to draw the letter of my choice. Here, letter is a character variable, and I give it the position X, Y. So if the letter is a capital A, Splat, we get a capital A on top of the photograph. Now comes the time-consuming part. I'm going to pass through the whole picture several times. So I'm going to visit every single pixel in the off-screen buffer over and over again. And every time I go through, I'm going to examine every pixel. And for every pixel, I'm going to swap it with one of its 4 neighbors. On a big picture, this can take a few seconds. But the result is this. A picture where the photograph and the letter have all been fuzzed and smeared out together. Now what happens when I want to draw this on the screen? Well, let's take a look at the draw routine. It's really easy. Draw translates first to the center of the graphics window. Then I rotate by some amount that goes up and up and up with every frame. I chose 0.02 because it was slow enough to look good. Then I copy the off-screen buffer into the graphics window by calling image. The first argument is the off-screen buffer. Here it's fuzzy. And I place the upper left corner at -half the width and -half the height so that the center of the picture is in the center of the graphics window. This is the entirety of draw. Remember that every time we enter draw, the coordinate system starts out in its default location, in the upper left with X pointing to the right, Y pointing down, both axes having length 1. So I could wrap this up between push matrix and pop matrix, it wouldn't hurt, but we don't need to. Notice that the 3 calls we're making here, translate, rotate, and image, I'm sending to the graphics window because they don't have a buffer name and a dot in front of them. If I wanted to send these messages to fuzzy, I would have had to say fuzzy.translate, fuzzy.rotate. But I don't want to do these things to fuzzy, I want to do them to the graphics window so they don't need an object. So let's run this. Here we are, the photograph and the picture have been fuzzed together. Now if I hit a letter on my keyboard, let's say the lowercase m, the picture stops because now I'm doing that whole complicated routine where I draw the photograph again in the off-screen buffer, I draw the character on top, and I fuzz everything out. Every time I hit a new character, here I'll hit the ampersand, everything stops while the new picture gets recomputed and then it just gets drawn on the screen using the simple draw loop we saw. So draw is doing nothing. It translates, rotates, and just splats the image. Every time I hit a key, let's say I hit the 6th key, then everything freezes for a moment. Imagine how hard this would be to do in any other way. If you were trying to draw this on every frame, then you would have that delay of 2 or 3 seconds for every single frame. And that would just be crazy. It would look terrible. But this way, I'll hit a lowercase g. Everything freezes just for a moment. But now from now on, everything looks really nice. So these are a couple of examples of how you can use off-screen buffers, either to draw objects that have some complicated transparency, or to draw things that you want to use over and over again, but take a long time to compute. Over time, you'll find other uses for off-screen buffers. They're not something that most people use every day, but every now and then you're going to have an application for which this technique is just perfect.